doesn't stay that way. Hello and welcome to ISU Media Message. I'm Bob Lindemeyer, the Associate Director of the Media Resources Center here at Iowa State, and it's my pleasure to be the host of this new series. We hope it's going to be a continuing series. The mission of the program is to give our viewers an opportunity to see a number of the films and videotapes that have been produced here at Iowa State, most of them not having an opportunity to be seen by a wider audience. They're produced for the support of classroom instruction. They're produced for public relations purposes of the university. They're produced for others around the state of Iowa. But seldom have we had an opportunity to share them with the larger audience, the television audience. And so that's why we're here tonight. In this, our opening program in the series, it's my pleasure to welcome Ed Rierich, who's Senior Writer-Director on the staff at the Media Resources Center. And Ed, you're bringing us two films tonight, right?
Right. One is called The Miracle of Corn, which is about a 7.5-minute film on corn. And the other is called The Hybrid Corn Miracle. Both of them have miracles in them, so.
Okay, both of them are a little corny and a little bit about miracles, huh?
Right, right.
Now, both of these productions were produced for the Living History Farm in Des Moines. And who was the moving force behind them, really?
Well, the actual founder of the Living History Farm, the late Bill Murray, who used to be Professor Emeritus here at Iowa State. And he came to us one day in 1988 and said, I want to do a film on a corn plant growing. And so that's what the result is.
Okay, and that won the Cine Golden Eagle among a number of other prizes, right?
Right, right.
Let's have a look at your Cine Golden Eagle just so people appreciate how magnificent that trophy really is. Cine stands for what, Ed?
Cine stands for the Council on International Non-Theatrical Events, which allows it to be shown in international film festivals representing the United States overseas. And so it's a great award to have.
Great. Well, congratulations. And without further ado, let's have a chance to look at Ed's award-winning film. Again, it's called The Miracle of Corn.
Over the course of a growing season, one kernel of corn will grow into a plant that may produce more than 600 kernels. If you were to plant 1 acre of corn, you might seed about 22,000 plants. If each plant grew 1 ear, and each ear had 600 kernels, that 1 acre would have over 13 million kernels. If you had planted 400 acres, you'd probably harvest more than 5 billion kernels of corn. Let's take a closer look at just how this corn-producing factory works by following what happens to a single kernel, the seed. Using the food stored inside the kernel, the embryo starts to grow in the warm, moist soil. A primary root shoots down to gather nutrients for continued growth. Meanwhile, the germinating kernel sends up toward the surface several rolled up leaves within a shield that protects them. About a week after planting, the new shoot emerges. The leaves break through the shield into the light. With the leaves out and the roots in place, the corn plant begins making its own food, the stored food in the seed having been used up. Food is made in the leaves by photosynthesis. Photosynthesis uses light energy from the sun to produce chemical energy, stored in the form of sugars. As the leaves grow out, so do the roots, which take in minerals and water to change the sugars in the leaves into proteins and other foods. As a result, the young corn plant grows rapidly on its own. The leaves, tightly wrapped around each other near their base, help support the plant as it grows. The tassel emerges, revealing thousands of small pouches holding the pollen needed for reproduction. Meanwhile, lower down on the stalk, the ear has been developing. Delicate silk-like strands emerge from the end of the ear. Each silk has grown from a potential kernel sitting on the cob, surrounded by the leafy husks. There are 600 or more potential kernels, so there are 600 or more silks. With both silks and tassel displayed, pollination begins. It's been estimated that as many as 5 million grains of pollen are produced by a single tassel. That's over 5,000 grains of pollen available for every silk that is to be pollinated. When a pollen grain lands on a silk, it sends out a tiny tube through the silk that reaches back to the potential kernel, the female part of the plant. Male cells, produced by the pollen, move down the tube to join with the female cells. This is called fertilization. It happens over 600 times on the ear, once for each potential kernel. When fertilization is complete, each of the new kernels has the embryo of a whole new corn plant developing inside. The plant is at its maximum height. It will grow no taller. Food production by the leaves now goes toward the developing kernels. Maturity. The kernels have stored up as much food as they can hold. 4 months after the seed was planted, the mature ear, with its more than 600 full new kernels, is ready for harvest. Harvest for feed, food, and other products for human use.
Well, you've just seen The Miracle of Corn, and my guest tonight is Ed Rurick, the filmmaker who made that lovely film, and I understand it has won a number of international awards. Tell us about those, Ed.
Right.
You've
One of
got
the first
more
ones.
hardware,
I have a whole
huh?
bunch of stuff here to show you.
Point it right at that camera.
This is
Yeah.
the won a silver award at Zaragoza, Spain Film Festival, and that was the first award that it won. And then I will show you another one. It won actually 3 awards. The second one was a first place award in Nitra, Czechoslovakia, which was very nice.
Nitra is now part of separated Czechoslovakia.
Right.
I think it's the part called Slovakia, as a matter of fact.
Right.
Yeah.
And the third one is the Berlin Green Week Film Festival, which was, it got this award last January.
The silver medal on that one.
Right.
Well, it is a beautiful film, and I think the audience would be interested in knowing a little bit about how you got some of those things to move, like the part where the plant grows up and up right in the middle of the frame.
Right. The vegetative growth was really kind of difficult to get because it's time-lapse, of course, and we had to figure out how long it would take for that plant to grow in that space of footage. And most of the experts didn't know how long it would take for that corn plant to grow that far. And they would just say, well, it doesn't take too long. But I needed to be a little bit more specific than that.
So you take a frame, and then it waits, and growth lights are turned back on?
Right.
And then
We had to film it in a darkened room because plants grow at night as well as during the day, so we couldn't use sunlight. So we had to go into a greenhouse in a darkened room and use a plant that was in its own soil,
Right.
and which was sterilized because we couldn't have any bugs or mites or anything flying around there because they would just pop on and pop off once every 10 minutes or once every 20 minutes whenever we would click the shutter.
Well, you must have had corn plants at all different stages of growth.
Right. We used about 20 or 30 different plants over the course of a 7-month period. And even though a corn plant only takes 4 months to grow to its tallest, it took us 7 months. But Mother Nature has several thousand years experience, more than we do.
I was also impressed with the little sequence where the narrator, incidentally, Doug Brown from WY Radio, the guy who reads the book club so wonderfully, where he says the tassel emerges and that all those little grains of pollen start to fall. Now, that's not time-lapse there, is it?
No, what we did was we had to do high speed. Now, that's just the opposite of time-lapse. We had to shoot about 400 frames per second and to slow down the gravity pull of these little pollen grains hitting the silk. And that was a little bit of a problem also, trying to catch all those little bitty grains of pollen because we had to get very close.
Mm-hmm. Now, I noticed frequently throughout the film you go back to this sort of high view of a great long, must be a mile-long cornfield. That was what, part of the ISU research farm?
Right, exactly. And we had a camera situated out on the end of that field for the full length of the growing season to take just one shot about every 3 weeks. And then we dissolved from one scene to the next to give that impression of a full year's worth of growth in 30 seconds in the last part of the over the credits.
Okay. Now, the other film that you're going to show us tonight, the Hybrid Corn Miracle, was also produced for the Living History Farms, right?
Right.
And what's the story there?
Well, the story there is that we're trying to show how hybrids are produced. And we used animation, we used in-the-field demonstrations to explain, for example, why, I know a lot of people have seen or have gone out detasseling, and they were wondering, why am I always detasseling these things? And this videotape will show them exactly why they're doing that.
All right, good. Let's look at it then. This is another award-winning film done by Ed Rarick, and it's called The Hybrid Corn Miracle.
What is this corn that we see row after row, mile upon mile, so even, so straight, so abundant? It's hybrid corn, the result of years of painstaking breeding and testing, a revolutionary product of science applied to agriculture. A 100 years ago, farming was a lot different. At the turn of the century, average national yields of corn had not improved much from the previous century. Fluctuations were due mainly to climate. Yields remained much as they had been before, averaging only 23 to 28 bushels per acre. During the mid-30s, average yields dropped because of drought. But in the 40s, yields increased to more than ever before. The reason? Hybrid seed was introduced. As we moved into the 50s and beyond, average yields were bolstered by the use of fertilizers and pesticides, improved machinery, more plants per acre, timeliness of operations, and better farm management. The major factor in these increases, however, was the continued development of better hybrid varieties. Today, virtually all the seed corn that farmers plant is hybrid seed, with average national yields of over 100 bushels per acre, 4 times what it had been only 50 years before. How did farmers accomplish this? They changed their way of getting seed. Before hybrids, farmers used open pollinated seed. That is, the silks of the ear on any plant could be pollinated from any of hundreds of different plants in the field. Each sister kernel on an ear may have had a different male parent. When the farmer selected the best-looking ear to save for planting next year, he was actually saving a variety of genetically different kernels. When he planted them the next spring, hoping to produce a uniform crop of high yield, he got only a diverse, non-uniform crop of average yield, not much different from what he had in previous years. Hybrid seed, however, is not produced by the farmer. It's scientifically developed by specialized seed corn companies, which then sell their seed to farmers. Because of nearly identical heredity, the hybrid plants have uniform resistance to pests and diseases, for example. They are adapted to the areas where they're grown. And because of their uniformity, they can be easily planted and harvested by machine. So, the higher price of the hybrid seed is offset by its dependably higher yields. How then is a hybrid seed developed? The process occurs in 3 steps. The first is to produce genetically pure lines of seed by selective inbreeding. An important characteristic of corn is that it has both male and female parts on the same plant. The male part is the tassel, which produces pollen. The female part is made up of potential kernels on the ear shoot, deep within the husk. Each potential kernel has an exposed silk attached to it to catch the pollen, making reproduction possible. Inbreeding is the carefully controlled method of pollinating a plant with its own pollen. The ear shoots are covered to prevent their silks from accidental pollination from neighboring plants. Each selected plant is carefully pollinated by hand. This inbreeding and selecting process may be repeated for as many as 6 or 7 generations until the plant's heredity becomes uniform. That is, all plants of an inbred variety will look the same and will respond in a similar way to the environment. Hundreds of inbreds are produced, and their resulting seeds are tested for the desired combination of traits. What are some of these traits? Good seed must have traits adapted to the environmental conditions in which it is planted. For example, the soil type, the amount and distribution of rainfall, the length of the growing season, and the prevalence of particular pests. One such test is for resistance to the European corn borer, an insect that's been a major threat to corn growers. After they're infested, the test inbreds are each evaluated to see which has done the best job of resisting these hungry insects. By the time inbred testing is complete, most will have failed to measure up and will have been discarded. Those inbreds showing the most desirable traits will go on to the second step of hybrid seed development, experimental or test crossing. The key to hybridizing is taking the pollen from one selected inbred and cross-pollinating it with a second unrelated inbred. The outcome is usually amazing. The resulting hybrid seed produces a plant the following year that's bigger and stronger than either of its parents. This is the miracle of hybrid vigor. The purpose of this test crossing is to find the cross of 2 inbreds that combines the desired traits and gives a higher yield than existing hybrids. Again, the same carefully controlled methods of pollination are followed, only this time the pollen from one inbred is crossed onto the silks of the other inbred. Thousands of inbreds are crossed. The resulting hybrid seeds taken from the female plant are planted the following year for testing and evaluation. This is time-consuming and expensive, but it eventually comes up with a winning cross. It's estimated that out of more than 1,000 test crosses, only one will produce a hybrid seed that will perform significantly better than had existed before. When the breeder has found a cross of 2 inbreds that produces an acceptable high-yielding hybrid seed, the third step begins, mass producing it in sufficient quantities for sale to farmers. Seed corn companies contract with skilled farmers to do this on a large scale with the assistance of the company. The 2 selected inbreds are planted in the same field in alternating sets of rows. For example, one male row of one inbred may be planted next to as many as 4 female rows of the other inbred. And it is these female plants that will eventually produce the needed quantities of hybrid seed. On these female seed rows, the tassels are removed to prevent any accidental inbreeding. Detasseling machines often remove the majority of the tassels. However, it will take repeated trips through the field to remove all the tassels by hand, because not all tassels emerge on the same day. Hand detasseling provides brief summer employment to many thousands of youngsters and migrant workers each year. Pollination occurs when the wind blows pollen from the male rows to the silks of the detasseled female rows. The resulting hybrid seed is harvested from the female rows. This is the seed that will be sold and distributed to farmers for planting next year. But if looks could sell corn as it did 100 years ago, this corn would not be saleable. Yet these seeds have in them the tested hybrid vigor that will produce an abundant crop for the farmers who plant them. Before distribution, the seed is taken to a conditioning plant where it's sorted, dried, sized, and bagged for sale to farmers all over the world. The farming of corn in the early 1900s was vastly improved by the introduction of hybridization. Today, yields are at least 4 times that of the 1920s, allowing farmers to export more corn to world markets, enough to make a significant impact in helping feed the world. This is the miracle of hybrid corn.
Welcome back to ISU Media Message. You've just seen the hybrid corn miracle, and my guest is Ed Rarick, the man who made that film. Now, these techniques of inbreeding the corn and then crossing the corn, that's really the fundamental of the way these hybrids have been perfected, isn't it?
Right, and I'm not a corn breeder or anything like that, so I'm just a filmmaker, but it took us a while to boil everything down that we were told into 3 basic concepts which could be easily told.
Both of these programs we've seen today are playing at the Living History Farm during the season when it's open. So if you'd like to see them again, that's a good opportunity to go and find them there. In fact, called the Miracle of Corn Museum at the Living History Farm. That's our program for tonight. I'd like to thank Ed Rarick for being here, and I hope you'll join us here again next week for ISU Media Message.